Welcome to the second of the Bartlett International Lecture Series. I should introduce myself. I'm Andrew Porter. I'm the Deputy Director of the B Pro programs. And really it's in connection with the B Pro programs that I'm here to introduce Claudia and Marco tonight. They have been teaching for the last year on the Urban Design program. I think there'll be a lot of you here from that program. Welcome. And this year we've asked Claudia to actually lead one of the streams. We're developing the program this year further. It's been a really interesting year over the past academic year, and there's a lot of interesting, exciting changes ahead. Claudia and Marco graduated from Turin. They trained then at the AA, and then they moved into working, I think, in the London scene. They've been published and exhibited widely. Their Cyber Gardens project is a really exciting project where the visitor becomes an interactive part of the exhibit and the author of the piece. And their latest, I think your latest book is the Routledge Systemic Architecture, which you should all read. They're experienced teachers. They've taught at Cornell, the AA, the IAC in Barcelona. I think they were directors of the fabrication department there. And at a first glance, though, their studio seems to be self-explanatory, the name. But actually the work is much deeper than that, and it doesn't concern itself with a kind of dull, overly ethical, joyless sustainability. It's much wider than that, and I think that their experience in the working world bears that out. Marco has worked for, very interesting, I think, for Battle McCarthy, and Claudia's worked for Eric van Egeraat, but also really interesting for me, Ashida Findlay, which I think are one of the most interesting architects working today. Their work encompasses, as I said, not just this kind of narrow agenda of sustainability. It's about system thinking. It's clearly about cybernetics. It's also about a deeply technological and a technological optimism in their work, which is great and refreshing. There's biotech, and they're interested in nanotechnology, but it avoids a kind of simple sort of biomimetic conversation with this. The work is also highly computational. There is a strong autogenerative aspect to the work, which is, for me, highly reminiscent of the evolutionary architecture of John Fraser. However, above all, the work is highly visual and well judged. Ultimately, they're real designers, and I hope you'll enjoy this aspect of their work tonight. I'll give you Marco and Claudia.
Do you want to keep it or I keep it?
We share it? That's the idea.
Is that little device there to actually judge us at the end? Okay, so thanks a lot, Andrew. It's really a pleasure to be here and to kickstart the International Lecture Series of this year. And obviously what we're trying to do is to synthesize a little bit the experience of research within Ecologic Studio in the last probably 6-7 years. So we're going to show a couple of projects that date back a few years, and we're trying to speculate a little bit with you the kind of trajectory that we have been following, and also that is leading to the ideas and the speculation of the new program that Claudia is directing, and I'm contributing as a cluster leader.
So the title of the lecture is, or talk, I prefer to call it talk and lecture, is Ecology Beyond Nature, which is an issue we are interested in, and especially is quite tightly related to the name of our office that might seem very simple, but maybe is not so simple as Adrian underlined. In fact, the name Ecologic Studio is not hinting to sustainability as you might think, but is related, well, that's very dark. So it looks like speaking to my computer at the moment, but it's okay, I will imagine you.
And normally there is a light on our face, right? So otherwise no one can even see us. Okay, good, okay, good. Anyway.
It's a mysterious light. So.
What is the camera recording like? Anyway, sorry.
Okay. Okay, maybe like that we can stay. So the name of Ecologic Studio actually comes from a conversation between Mark and myself on the book of Gregory Bateson, Steps Toward an Ecology of Mind, and in particular on the discussion between language and meta-language and how these can influence design.
So the idea of ecology beyond nature is really trying to understand whether there is an alternative to the current articulation of the green paradigm. Of course, we always have been convinced ecologists, if you want, in one sense, but at the end of the day, we've never been completely satisfied by the way architecture or the sort of creative side of our business engages the issue. And I think for us there is something much more generative and exciting about thinking ecologically than the sort of greenwashing material that we get to see today, and particularly when you start talking about kind of eco-cities or eco-buildings, etc. And so in trying to kind of open a polemic towards that, we looked for inspirations, and of course Gordon Pask and the sort of cybernetic movements which had quite direct contacts with the Architectural Association in the early late 80s, early 90s, sort of inspired us a lot when we first moved to London. So this quote is which I hope you read in the meantime, is really about trying to understand how the kind of understanding of ecology and of biological machines or mechanisms can be expanded and explored beyond the actual green facade of it, if you want. And maybe one project that we are going to show about to start, it's a fairly old project, 2007, but I think it's a good starting point to understand how we tried to tackle this idea.
Yes, during the presentation we will talk about different projects of Ecologic Studio. We are starting from the material aspect. Our interest in the relationship between architecture and material system and nature goes from the material scale to the urban one. We will start from a set of material experiment. In particular, this one is a simple experiment called fibrous structure or fibrous room. We did in Istanbul in 2006, and started from a workshop with students where we were exploring how we could create somehow complex geometry without a formwork. How material can become the geometry itself. We were in Istanbul, and you might be familiar or not with the Mukarnas. Mukarnas is a structure that they have there on the mosque, where there is an integration between decoration and structure in this stone that are entangled one with the other. We were inspired by that, and we decided to use concrete in this case and try to weave, bundle, and explore different ways of using fibrous reinforced concrete.
Yeah, the project really is quite simple. It's a kind of material, like gigantic material sample, almost like a chunk of an imaginary structure that would be organized in plan or in the front by this pattern, this Islamic pattern, Arabic pattern, which we found in Istanbul in many occasions. And then a set of fibers, of pipes, which were the kind of soft formwork for the concrete to be poured inside. So these kind of simple logics, in fact, became quite complex in the moment we started to articulate them parametrically. And so that was when the sort of computational elements of weaving came in. And we started to explore how, through the weaving of the fibers, we could create both a kind of resistance, material resistance, and at the same time strength and collaboration. So these are some images of the installation that was really imagined as a kind of a process in which the form and the material resistance were taking shape in time. So the idea of exploring time and interaction was really part of the experiment.
And this aspect of interaction and behavior has always been part of our work, even when we talk about structure or concrete, which is supposedly a little bit more static. And in this case, the prototype was exhibited in Garandi Gallery, which is a gallery in Istiklal, which is the central road of Istanbul. And the exhibition was really about the process. So the first part was constructing this machine to pour the concrete. And for a few days was exhibited, like you see it now, with this sort of secondary thread that will enable the visitor of the exhibition to deform the structure parametrically.
So the formwork was really a kind of a soft assemblage of two sets of fibers, one thicker that would become then the actual formwork for the concrete, and the other one which would work as kind of tendons and would allow the structure to be deformed and to find its shapes. Then one night the big Lafarge truck came and pour the concrete. So this was in fact also another element of the research. As many of our projects, they tend to have multiple layers. This was really trying to take advantage of a kind of innovation in the technology of concrete that Lafarge has been proposing for a few years, the fiber reinforced concrete. So this is a kind of really microscopic image of the fibers inside of the concrete, which allows you to pour really thin sections. This was a little bit what it was all about in the end. So all very conceptual, very interesting, but at the end of the day, it was a pretty dirty job. Of course, the gallery director was kind of extremely worried and concerned, but at the end of the day, everything went well. I think the interesting element was that we managed to bring something from the construction industry in touch with a very speculative exploration in the form and materiality of structures. And at the end of the day, of course, the project carried on as the concrete was beginning to set. You would get a kind of plastic behavior, so deformation because of the weight and because of the changing resistance would keep happening. The tendons would have to be reset and readjusted. So it's a continuous kind of process of feedback and adjustment and feedback and adjustment. And I think that was pretty much the whole idea behind thinking as a kind of formwork, as a process and as a machine, as a kind of device of manipulation. And ultimately allow the concrete to become protagonist, like to determine the final shape, the final articulation, rather than actually being completely defined by the form of the formwork itself, which is really the kind of notion of material behavior being explored. So there are a lot of elements about the connection, ways of actually connecting the fibers without completely giving rigidity, a lot of technical details. But I think the whole idea was to allow for this degree of freedom within limits, within a certain set of constraints that we could control. And we could allow other people to manipulate as well.
So this exploration of fiber brings us to the next project. The next project is the Metafolie Pavilion and has been commissioned by the FRAC in Orléans. Is now exhibited as part of Archilab and will become part of the collection after the exhibition is terminated. I have a sentence of Bateson here. Mere purposive rationality, unaided by such phenomena as art, religion, dream and the like, is necessarily pathogenic and destructive of life. And it's a bit of an extreme sentence, which I like a lot, and is part of this discourse about the relationship of language and rational language and meta-language. The set of information that go together with the rational language and make us understanding each other, but as well understanding space.
This project is it's very recent. Actually, it's just been completed and it's on show now in Orléans. I think we will go there with some of the students. It's part of the Archie Lab. I think the nice thing of having these two projects together is that on one sense they are the less green project of the one that we have been doing. And I think often these projects, people ask, no, what is ecologic about this? You know, it's just plastic and concrete and, you know, like some crazy digital model. And I think this is in a way like really what for us becomes interesting. Like, how can you challenge kind of assumptions about what is natural, what is artificial, what is ecologic, and what is not? And of course, the projects in themselves, they are not giving a direct answer, but somehow they are kind of opening, I think, a territory which could be explored by architects and designers, in which the use of technology, particularly digital technologies, material innovation, and a form of systemic thinking can somehow come together and coalesce into kind of new material system, new morphologies, new spaces. And this pavilion, it's a very small one. It's a kind of it's almost like a sort of a folie. That's why it's called Metafolie. But I think this drawing there's a kind of explosion of it. I think it captures what, you know, the way we imagine the kind of the manipulation of space. You can see here the way material system, the steel rods, electronic systems which control the speaker and the sound, the human ear, which appears somewhere here in the drawing, and so on. They all contribute to the definition of the space and the way it kind of evolves. What is a kind of zoomed in version which sort of defines the various elements. So again, the material and we used here is on purpose was really a kind of almost like a leftover of the industrial age, if you want. So recycled polypropylene, you know, steel rods, some MDF, like really basic material. The electronics components themselves were actually selected to be the most simple ones. The piezo buzzer, which you will probably see later, which are contained in each of these kind of tendrils, they are really the most basic way of producing or turning electronic signal into noise or into sound. And I think that the idea was, you know, how do we manipulate this material to create an experience that is somehow closer to what we perceive of nature or natural, or how that triggers our imagination and somehow brings it completely into a different paradigm from the kind of original materiality of it. And these are some of the drawings of the sound.
Yeah, these are some of the drawings that describe the interaction. There are 6 hubs. Each of the hubs is both a structural hub and a sensorial hub that register the presence of people and why they move. There is a swarm. There is a swarm of cricket going past.
So the experience of the pavilion is defined by these very simple devices, which are contained inside of the leaves of the pavilion. They are called piezo buzzer, and basically they do a little tick every time the current goes through them. But obviously you can play with the frequency and create this almost like cricket-like sound. And by playing with this idea, we actually positioned 300 of them within the pavilion, and we started to play with the idea of swarm. So how these little simple devices could actually operate together and respond to the presence of humans. No? These are some technical details that show how basically the material organization of the pavilion, the structure, and the kind of informational one are somehow related. So you can see the wires following. Following the lines of the steel rods, which also provide a structural resistance to the system. So it's really a kind of game of path systems, you know, kind of wrapping the basic form. The way of controlling, of organizing the behavior is what makes it somehow alive. And I think for me this is very fascinating because, again, the ingredients are very simple, but the behavior is quite surprising, and somehow it really feels has its own kind of nature. So with the help of Nick Puckett, we designed a little applet which would allow us to program and play with the key parameters of the codes in real time, and in particular this kind of let's say frequency and delay factor, which is this one, would allow us to create different effects. So in a way, when the frequency is made very high and the delay factor very low, you have a much more kind of togetherness in the sound, and vice versa. So this then is activated by the presence of human beings, so that when you move around, this synchronization is a kind of changed. The first, maybe one last thing. The first idea, the first way of programming it for us was actually quite a simple literal reference to what happens when you enter a field full of crickets, and normally you have this kind of a sound which, as your presence sort of changes because the area around you kind of gets silent, and then as you move along, it starts again behind you, and then the other one gets silent. So your presence actually created this activation, and we try to use just that as a reference to give the first set of parameters, and then of course allow the system to take his own behavior.
On the aspect of behavior, there is the next project, which is about cyber gardening, and introduce some of the organic aspects that we've been working on, the integration between inorganic and organic elements. This is a very simple experiment. It was a workshop with our student. I think it's quite cute, and basically it's a set of a swarm of fish drawing for us or for the student. In this case, we were working on the World Lagoon in Dubai, and the student built a set of apparatus to investigate how the lagoon environment could influence their proposal. In this case, the student was hacking an aquarium, and through a set of sensors that were recording how the fishes were moving, would drive the resolution of his first mapping or plan.
Yeah, this experiment was really a kind of a didactical one, if you want, but it was really trying to kind of materially test the idea of the feedback loop. How can you create a mechanism by which the effects that you have on the system actually affects you, and vice versa. So you have a continuous influence between the way, in this case, the school of fishes would move and feed themselves in the aquarium, the drawings, the patterns that would come out, the way you would react to them and actually change your feeding pattern, etc. So in this case, the idea of hacking is quite interesting because it kind of provides a strategy to interact or intervene in nature, which is not necessarily about protecting or preserving, but rather kind of establishing a sort of interaction, a conversation. So it's a very kind of active way of engaging with a kind of, let's say, natural system, if you want, or biological system.
And this brings us to the discourse about practices that could, from the smaller scale, influence the larger scale. I will start from Ortus and a set of experiments we did on algae farming and how this can be integrated in the architectural system. Algae farming is called farming, but effectively is at the moment the structure of algae farming in our factory, often far away from the city, that produce energy, grow algae, and have no connection with the urban structure.
Yeah, when we first started to work with this microorganism, the idea was really to try to pretty wildly imagine a whole series of devices and scenarios by which algae that we would find in the urban environment, like in ponds, lakes, etc., could be relocated within architectural context. So, for instance, this is an experiment in Milan within one of these typical courtyard, and you know, we sort of transformed the courtyard into a kind of water percolating system, and then inside the bags, kind of a algae cultivation system. Another very simple experiment we did a few years ago, kind of bottling algae with different intensities depending on the kind of insolation levels, and then really sort of creating almost like a direct biological screen. So the more sun, the more algae would grow, the more shadow would cast, the less one, etc., etc. So sort of self-regulating system. Again, very, very simple in this case, but like conceptually the idea of self-regulation, the idea of kind of cybernetic is still there. And we are trying to understand, can we do it, can we achieve it with biological living organisms? This is a bit more sophisticated experiment we did in the Museum of Science in Trento, working with the scientists in residence, like really trying to create a lab in which algae he found in the alpine lakes would be kind of grown and experimented. It's almost like a kind of a biodiversity bank of algae. Another one in Seville, maybe we don't get into detail, but just to give you a sense that it's been like 6 years in which we have been using opportunities like such as installations, biennales, and various commissions to kind of develop really a language, but also a technical sensibility towards that and towards how we may be able to integrate this within an architectural language.
This is prototype, an interior that we did at the Architectural Association. In this case, the room was thought as an algae farm itself, with algae of different color that could be used for different type of purpose. The way the people that were inhabiting the room would interact with the system is both by providing CO2, therefore cultivating the algae, then by actually interacting virtually, mainly scanning the QR code that were on the bag and getting information on what they could actually do with this algae.
Okay, this is a trick. I messed up a few slides.
You've messed up the
but anyway, I could see you were. No, for me the interesting point that here was through this research we met a biologist and somehow she was making a point saying, okay, much of the research is going into farming, developing algae in the lab as a way of extracting, as a way of developing species that would be optimal for energy extraction, for food, for biochemistry, etc. But she was saying, actually, algae exist everywhere, exist in the urban environment, exist in the landscape, and that kind of proliferation somehow escapes our knowledge, our control. So we started to think whether there could be a relationship between the very large scale of the landscape and these actual prototypes, these environments that we were creating. So, for instance, this one had the interest of being an algae garden in the sense that, as you can see by the colors of these bags, there are different species of algae which represent a kind of a pool of different organisms that can be found in the very large territory of Osterlin. Why Osterlin? Of course, this is a project that came about to our studio a couple of years ago, and in which the region of Osterlin, which is in the south of Sweden, asked us whether we could engage with the problem of algae at the regional scale. This happened through this biologist I was mentioning, which is researching in Simrishamn, which is this little town here. There is a marine research center there. And so somehow we found that this new opportunity which we thought about before but never quite encountered, in which we could think of algae as a medium to discuss regional development or to discuss master planning, if you want. And that was a quite big kind of discovery somehow. And we tried to deploy the techniques that we knew to really understand how such a microscopic scale could be mapped throughout the landscape. And so we developed, of course we did a bit of research on the different regions of the area, the different marine or aquatic environments, and then started to develop a series of maps that would both captures the kind of a natural medium, but also the kind of networks, economic networks that is existing in the region. One of the ambition of the local municipality was, can algae become a driver of development, of regeneration? And so we started to understand how different species may actually serve different type of industries. So, how algal microorganisms, in fact, are useful to many activities and actually can generate wealth. And these, of course, looking at industry, tourism, so research as well, and try to connect that with the landscape. So we created these type of maps that were sort of cross-referencing biological organism, industry, and areas in the landscape. And by doing that, we started to evolve more specific type of maps. And I think this also became evident at some point that we could not necessarily kind of impose a final solution. So the whole idea was, how can this become a framework of development which has got the elasticity to engage the possibilities from the ground, from the local farmer, from the fishing industry, from the research industry that is already there, but of course push for a kind of concerted effort.
These are some of the some sketchy of some of the prototypes that we've been developing. We have more developed drawing, but we cannot show this yet. We are developing a pavilion for this site, and a similar pavilion has also been commissioned by Expo 2015. Will be on the Future Food District, which is curated by the MIT. We have been working with Vector Foiltech, so this is very sketchy, but the idea is that some of the photobioreactor we have been developing in the past could be realized in ETFE. These are some other studies of
so in a way it's about in a way, really what we are trying to do at the moment on this type of project is to actually take an existing technology which is used to create soft adaptive facades, to embed the logic of farming of photobioreactor systems and actually create a new type of facade or roof components, which could be applied in scenarios like this one, or as we are working at the moment in a kind of Expo, like really as a test bed.
We look at different prototypes. Some were more related to existing farms, some other tourism. So there was this idea of the underwater museum, so the tourists being involved in the cultivation.
So somehow the prototypes really become a way of kind of spatially, architecturally articulating these connections between a kind of new technology, a new microbiological system you introduce, and conditions that exist on the site. So farming activities are already there, dismissed port activities or marine activities because the fishing industry is decaying, etc., etc. I think the way this kind of one-to-one experiment worked here, which for us was also a kind of revelation, it really became a way of, on one side, test the kind of spatial effects that algae could have, but also to really directly engage the kind of user, if you want, of the space. So suddenly what becomes an occupant of a room also engages actively in the production, in the cultivation, and in the manipulation of the space. And there are a lot of little elements, from the actual oxygenation cycle. So algae absorb CO2 at an incredible rate, so they are a CO2 sink. They convert that into biomass, but at the same time they release oxygen, which you can see with this microbubble. So this, of course, has a direct benefit in the environment. It can be coupled with building systems to absorb the exhaust of the buildings, mechanical systems as well. So we actually began to go quite in detail on how this system could effectively become part of a kind of building organism and kind of change the metabolism of buildings as such.
but as well be calibrated in terms of its aesthetic. What does it mean to have a bubble as part of the space in which we are immersed? What does it mean to have a gradient of color that are not artificial color, but they are continuously mutating according to the type of interaction that they have with the user? Which is effectively the idea of the garden, but a little bit more artificial garden.
I mean, it really extended the whole notion of you know, maintenance, post-occupancy to a cybernetic framework. Like normally when you propose a living system in a building, there's always the problem who maintains it. And actually what we were trying to explore here is, can you create a system that is much more integrated in the space and in the life of the building, such as that, you know, the kind of maintenance become part of the daily functioning of the building itself, and somehow interweaves with the other activities that, you know, people are normally doing in urban environment.
Yeah, this is part of the cyber gardening I was mentioning before, where the user could actually scan the QR code, get a view, macro view, micro view of the algae, but at the same time we could get the information of where the user was located and how it was scanning, and it was becoming part of our cyber garden. So it was becoming part of a database of information of how people interact with the garden itself.
Yeah, I think we have obviously also to thank Emmanuel Ko, which is one of our collaborators, which helped in this interface. And again, I think the idea to insist on the relationship between the physical and the virtual, for us it has become really obvious with this kind of experiment. Because of course there is some knowledge you acquire directly with the physicality, but it's also information that, you know, has to do with the microorganisms, with the way you interact with them, who else is actually part of the system, how much energy can be produced, etc., which exceeds the direct contact. So the idea of actually having a mediating platform, a larger platform, it can become really a kind of powerful way of evolving or turning this master planning idea into reality. A tool that kind of moves this notion of adaptive master planning from the paper or the virtual model to a really a kind of dynamic real-time interface or platform, which is used on a daily basis. Maybe this is just another instance which is quite nice because it's kind of adds another element to the exploration. It's a show that we had just completed recently in Paris. So again, all these kind of expanded spatial effects that come with the idea of a system that continuously moves, produces, grows, harvests, etc.
This brings us to another scale of investigation. This is a project we did with MIT 1 year ago. And was an invited competition for a city for atomic and renewable energy. So again, the relationship between the infrastructure and the city. In this case, our role was related to the development of an algorithmic protocol for the city to develop in the middle of the desert, really, not far from Riyadh. And in particular, we started to work with the Wadi condition. The Wadi are the area where the water accumulates when it rains and where oasis sometimes develops.
I mean, for me, this project is interesting. Like, wait a second before starting the video, because somehow the scenario, it's not very dissimilar from the Swedish one, in the sense that the ambition is, can you create a new city, a new development from somehow the opportunities on the site. So can you create a city which is not only a test bed for renewable energies, but also it is able to generate more than it needs, and it becomes a kind of power plant. So can a city be a power plant? And I think what was completely different was the setting, right? Whereas in the kind of Swedish project, somehow there was this idea of kind of embedded adaptive system. Here in the kind of Saudi Arabian kind of mentality and mechanism, so that it was really a kind of King Abdullah wanting the new city to happen and to work. And so somehow the whole context of the project was sort of influenced quite heavily from that. And I think this is also a contradiction that we may kind of point out again later, because for me it really has to do a lot with the new master that we are promoting here. And I think how can we kind of explore more in depth these scenarios. So there is a warning. The video has got a highly rhetorical and ideological content, but I think it expresses really well what the whole project was about. And the video is actually made by Squint Opera. It's London-based filmmakers.
We live in a beautiful world, and though it is in decline, we have a precious chance to save it. Our proposal for KKR offers a bold and beautiful solution, a carbon-negative oasis growing from the wadis west of Riyadh. KKR learns from the laws of nature, nurturing the city from the nutrients of its environment, growing it like a plant from its soil. Our proposal deploys a groundbreaking digital algorithm using powerful computation to accelerate traditional city growth, rapidly evolving the optimum solution. This algorithm analyzes the climate of each and every wadi, scouring the site for shade and shelter. The wadis collect each precious drop of rain, nourishing the landscape of the parks and farms. An intelligent grid subdivides the terrain, searching for idealized connections between the plots, generating a range of routes that branch across the site, carrying car, bike and foot traffic. Buildings rise in concert amongst the plots, adapting in a chorus of feedback and response. The city arises like the soaring cliffs of the site, the next evolution of the ledged plateau, nestled in shelter, nurtured by nutrients, slowly emerging like a flower from its folds. KKR will be the most energy-efficient city in the history of the planet, harvesting wind, sun, and daylight, carbon negative, not just neutral. Buildings and landscape use closed-loop recycling, filtering water and waste as harmoniously as nature. Nothing is wasted, everything is connected. The streets are threaded with smart sensing infrastructures, constantly monitoring and improving the performance of the city. The urban operating system providing real-time information, maximizing connectivity and self-awareness. The parametric design system allows maximum adaptation, reshaping small spaces to optimize views and comfort. Cool private courtyards bring shading and planting, places of rest and peace and contemplation. KKR promotes a simpler, cleaner, easier lifestyle, symbiotically and organically marrying humanity and nature, bringing peace and harmony, comfort and ease. KKR offers a new kind of sustainability. Its new technologies enable and improve older traditions of sustainable living, continuing the Islamic practice of the stewardship of the land. KKR will be a living, responsive, real-time city.
Okay, so basically it's almost finished, but like okay, obviously this is the extreme, no? It's the perfect city. Everything works. Everything is super. And I mean, in a way, it kind of responds quite directly to the requirements of the competition. But I think that for me, what is kind of interesting of where we stand now is, on one side, there is clearly, as you mentioned before, Andrew, a kind of certain optimism, no, towards what we can do how we can deploy the technology, the research that is happening in different disciplines, science, art, etc. But at the same time, of course, there is the necessity, I think, as designers to find frameworks to develop these. And somehow we, on one side, confronting yourself with such a brief, and at the same time doing the kind of research like we were doing in Sweden, almost like a kind of, allows you to test, no? the two extremes of how you can develop and deploy a certain methodology. That's somehow, I think, where the research we are trying to bring in our BioUD and also the new academic stream in urban design sits somehow. It's kind of discovering the extent of this range. Here there are some slides which describe more in detail what we did here. Maybe we can. I mean, of course, the site was pretty much a kind of a virgin wadi or landscape, and this is a little bit how we tried to.
We always like to have a direct sense of the site. That's me, climbing the wadi.
Yeah, it's part of our adventure trips. But I think, in a sense, the whole idea of this kind of urban algorithm that the video was mentioning, that's what we tried to work on, and this was our contribution. And somehow this diagram tries to break down the way this algorithm may work, and we have on top what we call like the environment, so a series of indexing maps which try to capture the opportunities, the articulation of the environments. The prototypes part introducing let's say typological instances of building, infrastructure, and landscape, and then the sort of kind of virtual cells, the articulation, the resolution of the city, the networks, the emergence of path systems, and then the neighborhoods, the organization of areas within the city, followed. And I think, of course, we don't go into detail.
In this case, probably the algorithm was not about, the use of algorithm was not about understanding the complexity of an existing city or a very complex terrain, to understand if there is sun or not in Riyadh in a certain site. It's quite obvious. But on the other hand, it was allowing us to try and develop a tactical proposal that will have more connection in terms of system to the original urbanization that was about tents and nomad that was on the site, in comparison to the proposal that are developed at the moment. So the algorithm, rather than working on understanding a complexity, was enabling us to try and have a real-time relationship with the proposal we were developing.
I mean, one of the questions which I think was interesting was, if the city is supposed to be a laboratory, a test bed of new technologies, is it possible to imagine these new discoveries to influence the morphology of the city, the way the city evolves in times directly? So is it possible to write an urban code that would not necessarily prescribe the city fully, but that would allow for this kind of feedback to occur even when the project would start and would unfold?
I'm always fascinated by talking with some of the people that live in the desert, and the way they talk about it, and they just describe pattern basically, and they have an understanding of them that it is quite incredible. So it becomes interesting to understand how our city can map the system and eventually adapt to them in a tactical way.
So I'm just going a little bit faster on the slide so that we kind of move on. But the idea is that a series of different algorithms were applied to progressively develop the structure, the articulation, and the infrastructure of the city. These are interesting examples of the street pattern being tested in relationship to natural ventilation. So the kind of differentiation between streets according to their orientation, could become a new engine, and so on. So the development of the city works as a kind of feedback loop as well within the algorithm, but hopefully in our mind, also in the moment it's applied.
This part?
Yeah. But I think maybe, Claudia, you go for it. I just shift a little bit on the other presentation.
So this brings us to the last bit of the presentation, and on commenting the work that is just starting now, so probably the lecture is a little bit premature on this, but start from the second slide. Okay.
Yeah.
And presenting the brief of the work that we would like to set up in the stream on urban morphogenesis that we are starting here at the outlet. Our interest is on global city, but not on global city per se, but on how global city could be redefined, not simply as city or as these images we see now, but as the series of network of infrastructure and smaller development that are connected to them. And in fact, one of the main interests is these resource-driven boom towns that are growing as in connection to global city and as a long extension of them. We're interested in them from different point of view, from the fact that they create an ecology with the city, but we're interested also on the fact that create a new form of artificial landscape, almost from an aesthetical point of view.
Yeah, I think what we were mentioning before, it's really somehow critical to this view. If we look at cities, let's say from a non-anthropocentric point of view, or from a systemic point of view, if you want, suddenly there is the possibility to understand them as part of a larger network of interconnection of systems, and particularly there is the urgency, if you want, to explore the conditions that made the city possible, or on the other end, if you want, the sites that are intensified triggers as a consequences of the emerging of global centers. So there is again a kind of feedback loop happening between key nodes in the sort of global urban networks, attracting a lot of flows, of human flows, resources flows, and at the same time along these paths, along these flows in different sites, perhaps also very remote from the cities themselves, the kind of opening up of new scenarios of, in this case, kind of mining, exploitation of the landscape, but also of urbanization, of transformation of the landscape itself.
And what we mean with morphogenesis is not only on the tectonical point of view, therefore not only how the actually morphology of the tectonic of the city can be generated, but how this is tightly interrelated with other systems, energetic system and social system and political system, and how can a non-typological and analytical approach can enable us to map this information and transform them in proposal for the city, mainly transform them in something that is not pure analysis, but is a design proposal.
So, of course, this comes from a realization that, you know, the sort of notion of the city as a kind of urban center, it's transformed when you look at the incredible amount of interconnection, like both physical interconnections and virtual or digital ones that exist today, and that, of course, are becoming visible through mapping technologies that we can all access. Some of them are actually accessible open source as well. So, as we were saying before, the kind of negative, let's say, of the urban centers, like the areas that are less known, less explored, but they are actually critical in the sort of dynamics of urbanization today, interest us a lot. And I think this also relates to the kind of sort of ambivalent position that we found ourselves in a situation like the project of Caquer. Which is like clearly an example of a sort of, let's say, city from zero, which emerges out of the necessity to generate new resources, to make a transition, in that case, from an oil-based economy to renewable energy economy, but it's still about attracting resources. So here we obviously we have a catalog that we also discuss with the students, which is really related to a series of cities we have been working with that have different type of dynamics. We go from kind of manufacturing cities, which of course attract most of the raw material, and to sort of a finance city, if you want, or service city, I should say, as Dubai, where okay, the growth is really related to the necessity to create critical mass within the urban development. We looked at we worked for quite a long time in Caracas in 2003, looking at this kind of juxtaposition between what is kind of normally understood as a sort of formal planned part of the city and the part of the city that follows different logics. We could say bottom-up logics or kind of local neighboring logics, trying to understand how we can begin to approach this level of complexity. And I think this is something that, this is La Paz, another project that we have been doing a few years ago in the Architectural Association. All realities in which the kind of magnets, the force of attraction of the city results into its expansion beyond the realm of planning or beyond the kind of control as we understand it. And again, what we are kind of focusing on this year, and I think in the next few years of research, is pretty much the sort of counterparts of that. So the sites, as Burtynsky called them, kind of manufactured landscapes. These pictures are from him, from the photographer Burtynsky, of areas, for instance, the tar sands in Canada, this one, in which kind of vast regions are transformed, infrastructured to provide resources. And, typically these are seen as kind of scars, as a destruction of the environment, which, partially are. I mean, if you look at the kind of ecological impacts of them, but at the same time, they possess their own beauty, they possess their own kind of relevance, and we wonder whether this can become discourse or material for urban design, and whether we can actually create a much more clear relationship between what happens in dense urban centers and into this kind of agri-urban territory or industrial territories.
Yeah, these are some examples from actually our students last year, and now we try to develop a simulation to effectively compute the complexity of the city. You want to say something?
Yeah, obviously, one of the key points of UD2, of this academic stream, is to engage with digital technologies, which is something that, of course, you saw as part of our work and our research. But here is really also trying to borrow from other disciplines. And, for us, the excitement of being part of UCL and as part of a larger kind of academic environment is really that there are departments in which techniques and simulations and understanding of dynamic processes are developed and studied for many years. And it is actually become now possible to borrow these techniques and this understanding to perhaps develop new urban strategies or new ways of looking at the city. These simulations are actually quite simple examples somehow, but like really sort of define ways in which kind of algorithms that perhaps are developed to be applied in chemistry or microbiology can become relevant for urban design. And I think this is not just simply to say that you can take one tool and use it to make a city, but actually there are patterns, there are behaviors, there are kind of organizational principles that are shared and can be shared at different scales, and actually can help, I think, the designer to develop a different sensibility towards controlling complexity. Often the question is how do you engage something that escapes your understanding? How do you create a method to do that? And I think this is really what one of the core elements of this program.
Yes, how do you develop control on larger systems without controlling the single element? I think these will be themes on which the different clusters will work on and the student, and maybe we can close the lecture here. Do you want to show something more?
I don't know how we are with time. We can do a few more minutes. Yeah. Okay. Good.
Okay,
So yeah, I mean, I think it would be interesting to show a few of the examples of this year, and you know, for instance, in particular, our academic stream, our cluster called the Bio-Urban Design. We looked at biomimetic urban strategies to inform the kind of design or the strategic elements of the city. So one of the projects that was quite interesting was looking at ant behavior, and of course I'm not going to go too much in detail here. Some of you probably know the research that has been done on social insects, and you know, in particular the leaf cutter ants, which is this quite extraordinary sort of biological organism which is able to create very complex nests, very complex architectures, very complex path system to harvest food and even to process it. So the way, for instance, leaves become substratum to grow fungi, which are in fact what the ants are feeding from. But to cut the long story short, of course, one of the questions was how such a tiny brain can figure out such a complex task. And this is something that was understood probably around 20 to 15 years ago because of computation. So scientists were able to actually run a series of simulation and try to see whether they could match this kind of behavior. And it turned out that few simple rules can actually generate such a level of complexity when applied to a large number of individuals, large number of simple individuals. And this is one of the simulations. Again, we try to have a kind of scientific, if you want, method applying to this, in the sense that we try to run parametric studies, we try to compare what happens when you change one condition, one parameters. This is not necessarily really to turn ourselves into scientists, by no means. It's more a way of beginning to develop a certain sensibility towards computation, towards control of complexity, which again begin to operate at a different level. Once you have that sensibility, suddenly you can design with it. So you can take decisions that are outside of the model. So of course, because we're not dealing with ants, so we needed to make a step out of it. But clearly there is a lesson to be learned there, and there is a lot of work that can be done. Again, these are some other examples of running simulations with different parameters and observe what comes out. Engage time as a dimension of urbanism. Of course, you saw it already in our work before, but time is critical when you talk about feedback loop. The kind of what happens next is determined what the condition of the system now. So it's a continuous kind of unfolding process. Here are some of the images of this project that we developed this year with the students. Another way, let's say, of looking at computational technologies is to read the context. So on one side, we try to create models, strategic models. On the other end, we try to increase our ability to draw complexity. So as designers, drawing is our way of making sense of things, but also communicating them to other people. So how can we increase our ability to draw complexity? And of course, again, there is maybe what happens now, it's completely different from what you could do 5 years ago. So it's not just bare optimism towards technology, but it's really the kind of understanding that there are tools that are being developed for whatever reasons, and we can appropriate to our own means.
And also our map can be the starting point of the design for the student. This is a very simple map, but it's developed by Nike. They are trying to develop a product, of course, and there are several shoes that has got a sensor inside. And this map is actually generated through these shoes. And you can imagine that through sensor in the city and through people running, you can start to develop proposal, because this could become a map of differentiated material inside of the landscape of New York City, or other type of association that students might develop, not only from simulation that they run inside of the computer, but from gathering direct data from the city.
Cyber situationism.
Cyber situationism, yes.
Then, of course, the idea of scanning the landscape for natural patterns as well. So understanding, for instance, the water flow. This beautiful drawing is again trying to understand how erosion and is actually influencing or affecting a landscape, and then slowly turning these into more established drawings and somehow really bringing the indexing effort and the modeling effort together to create a kind of project scenario. Some other images from this year. The kind of biotechnological elements, we don't go again into it. We just saw some, I think a lot of the work we've done in this sense and how we think of it. But I think there is an important element which I think we'd like to underline. And I think one of the big, hypocrisy of like sustainability is how slow technology has developed in that sense. So of course, we are all quite impressed by this enormous power plants and the possibility of 1 million mirrors to condense, to focus the radiation of a sun in one point, generate incredible heat, energy from the sun. It's all great, but actually everything is achieved through 1 million pieces of glass plus steel plus a little motor plus cabling, etc. Somehow we want to question, is that really the best technology to achieve the purpose? Like in other words, it's interesting how in some fields things have been going so fast, whereas in the application or in the attempt to metabolize energy resources into usable products, we somehow seem to be very far behind. So in a way, there is an interest in what we were looking at before, the kind of urban or landscape dimension of biotechnologies, in the sense that they may become the kind of substratum underpinning a new generation of cities or a new generation of urban developments, really where the bacteria somehow become the protagonists, we can say. And I think this is not science fiction in a way. It can be articulated into a pretty realistic propositions. This is something that one of our groups this year looked at, for instance, for the Tunis Lake, creating a sort of a biotechnological surface of skin, digesting the kind of the pollutants in the lake of Tunis, and so turning it into kind of usable raw materials. And these are some of the images of this kind of airy surface. Each of these kind of artificial grasses were supposed to be covered in biofilm and actually become sort of active digesting elements. Or another project looking at the bacteria existing in the lake south of Tozeur, where in fact scientists are already doing research because they could see the potential of using this microorganism in large scale agriculture. Again, looking at them as a sort of underpinning of a new civilization based in the lake, producing, exporting energy, and creating sort of new kind of material prototypes. I think on this we can close. The scenarios are normally the final elements. This year we proposed 4 of them, but again, this is the first year. I think we are going to try to develop this into a much wider catalog. And of course, this year, maybe you, Claudia, want to finish mentioning that there are going to be 2 new clusters working on this. So overall, around 50 students, and it's going to be, I think, a really exciting year ahead. Certainly looking forward to it.
Thanks.
I think we still have a little bit of spare time for some questions, right? Yeah, I mean, if you have any curiosity, I think you may want to go ahead and ask them.
For the Cape Care project, so can you speak a bit more about the algorithm you used
Well, basically the project it was an invited competition, right? So we were in a sort of competition stage. We obviously didn't have real sensor there, so all the input data were based on simulations, right? So the idea is that we did a series of analysis and we tried to understand the kind of key elements of landscape in terms of solar radiation, shadow, water, and kind of topography, articulation of the topography, and this became the sort of substratum, let's say, to develop the algorithm, which then started to subdivide or tessellate the surface, create plots of occupation. Each plots were computed in terms of what they could give, what they could produce, and that would basically create the possibility for infrastructure to emerge and so on and so forth. The idea of the kind of bigger concept which the video tries to describe was in fact that since the project is meant to be a kind of experimental city which basically is inhabited by researchers and so on, and so it's like really a kind of let's say living lab or test bed, which is kind of a nice idea. But we thought, okay, such a kind of fertile environment for innovation should be designed in such a way that the kind of new discoveries or what is understood from the testing could actually inform directly the way the city evolves. No? So actually there is a sort of continuous feedback. So the idea that what was now simulated could be in fact fed by real data, and so what the video was talking about, the idea of kind of monitoring systems and a kind of a distributed intelligence of the city was the kind of obvious vision for that. And in that sense, the digital algorithm, the way we were designing the city, was such that we could imagine the information that now was coming from just a pure digital simulation could be fed by real data, and possibly the two could run together. You could have like real data coming in and a digital simulation kind of expanding, what if in the next 30 years, etc. No? So you have a kind of a real-time feed, live feed coming in, and then you have a kind of diagnostic that sort of runs in the background. No? And this is the kind of, this was the kind of vision of how this may be functioning.
In that project, as I was saying before, we were working as a team, so we were mainly working on developing the algorithm and the kind of topological response to that, and how you could combine different parameters and start to develop the morphology of the city. Then with us there was Carlo Ratti and the Sensable City from MIT, and they developed a set of kits testing different types of sensors and how they could be embedded in the material system of the city. So it was a teamwork. There were also other groups in the team, but the relationship was that we were developing this part and they were developing more the material aspect, and we were to embed the sensor and the technology and etc. They did a few projects on that, so that was the type of collaboration.
There was a lot of discussion, which I think was very interesting, between this idea of real time and soft real time and delayed time, etc., etc., which MIT people are really keen into. But like I think the genuine interest, and we have one here, the genuine interest is like, how do you treat time in this case? No, because of course the simulation is a way of fast forwarding time, if you want, or like a kind of running scenarios. But at the same time, you can have like live feed coming in, and then one can process the other and feed back into the other, etc., etc. So one of the interesting conversations we were having with MIT is like, can you have systems of monitoring distributed in the city, which together with the algorithm that is actually spatially distributed as well, like you actually can create a form of distributed intelligence. No? So almost like the city in itself has the ability to kind of understand a little bit what is happening there, process it, activate something on the other side, and so on and so forth. No? So there is a kind of idea of distributed intelligence, and again, of course, there are different biomimetic models for that, etc. But maybe you don't even need that. I think it was really like the discourse was really, how can we couple a kind of algorithm that works spatially in a spatial model on the territory with real sensors that are distributed in the same territory and they can actually feed each other, right?
I have one question that is related to probably what you asked and probably what you just explained. It's kind of twofold. One is a disciplinary question because the work you're doing is inherently inter and at least that and probably more multidisciplinary. And maybe you can speak a little to what kind of other disciplines you're working with and what kind of new synergies come out of that process. The other is related to call it the verification or quantitative or qualitative analysis, and you mentioned simulation.
Yeah.
And maybe you can speak a little bit to what kind of simulation processes are those, who is involved in creating those processes with what kind of expected results.
Yeah, the two questions are quite connected, and it's interesting. I will refer to another project actually, the one of the prototype on algae farming that we've been doing. We work so tightly with biology for a long time in developing this project. And what it was quite peculiar is that, in a way, even though we will get a lot of knowledge from biologists while working with them, they always had a sort of mistrust because they are used to frame their discipline in a different way. And somehow, in a very banal way, I would say, come on, I grew up in a farm, I can cultivate algae as well, maybe. But for them, the whole process of cultivating algae and extracting energy is something that you frame in a very rigid, disciplinary way. And they don't see it out of the framework most of the time. So I think for us was really a question of taking the parameter, the number they were working with, and the biological aspect, the color that were coming out of the algae, and transform that in a palette of information to generate a space and morphologies. And that is something that is possible to translate also at the urban scale in a way, no? So
well, in fact, it was
when the simulation is not purely a computation simulation, but becomes as well tectonic, no? That's what we were discussing. Sometimes when we develop what we call the operational field, that are maps that effectively gather data and represent them, no? We are questioning on the aesthetic of it, but the question is not whether the map is aesthetic or not. The question is that the student need to be aware that a certain type of line associated to a number can generate a different proposal from another one. So that's where the designer intervenes. You know, you have a set of morphology that are related to a set of process, and you need to start to work with them and develop your own technique to effectively have a design proposal.
I think, for me, in that sense, like the question of simulation is very interesting because, like, somehow, what is a simulation, right? I mean, normally simulation is, you know, kind of attempt to predict, no, what could happen out of a set of starting conditions, and you know, you can have different type of simulations, some, you know, like long term, shorter terms, etc. But in a way, it's a kind of prediction. The way you deploy the results, or the way you kind of interrogate the results of the simulation, can lead to a completely different way of intending or using simulation. So often I think we often end up kind of maybe misusing certain techniques as you would normally look at them, with the purpose of actually trying to interpret the results differently. So how can a kind of algorithm that, I don't know, optimizes the capturing of insolation actually doesn't lead to a kind of single solution, but perhaps feed a kind of a larger framework, a larger process of morphogenesis, or a larger process of differentiation, and therefore becomes generative. So how can we interrogate kind of engines of simulation, not so much to narrow down the options, but to actually become generative, no? To become productive. And I think this perhaps is the way in which we also with the students. No, we try to appropriate tools that comes from different disciplines, and we try to kind of instantiate them within a framework, a methodological framework, if you want, that is really focused on design. It's focused on actually generating new proposals, new visions, or new morphologies, if you want. And it's a tricky business, of course, no? Because sometimes you can actually really kind of misunderstand what comes out of it, or you can get results that are fairly incoherent. But at the same time, I think it's an interesting way of a kind of expanding the relationship with scientists, which I think is recognized by scientists itself. I mean, it was actually one of the biologists we've been working with, Catherine Legrand, which first suggested the need to look at the kind of larger picture of the landscape of Austerlitz region in terms of a kind of algal ecology and cultivation. So, for instance, it was her who said, okay, what we are learning and developing here in the lab should be inquired in the larger picture and should generate new kind of protocols, new vision, what you can do at a larger scale, which actually for us was pretty kind of radical somehow to listen from a scientist, and it actually gave us some really interesting clues. So yeah, I suppose, I don't know if that answers your question, but I suppose that's the kind of way we try to intend, let's say, transdisciplinarity or the collaboration with scientists. And I mean, I think hopefully this, this environment and this kind of new adventure with the master will be really also a kind of fertile terrain to push this further. No, I mean, we are by no means kind of accomplished in that. I think there is a lot that can be done, and I think this, UCL, I think, should be really exciting for that. So.
I think. Well, okay. One more.
One more. Two more. No, one more, Chris.
Thank you very much. Very interesting. I think predicting the future is very exciting business to do. But if we think of cities, obviously there's many different things, but one of the big influence on cities is transport. People around, civil traffic running around. But are the future cities going to be that nobody wants to actually move around anymore? They've got everything in here, the neighbourhoods, and they've got IT, and why are they bothering travelling all these distances and wasting this vast amount of energy? Could you predict whether the world was a better place if we got rid of transport altogether and just relied on the old-fashioned bicycle and think of neighbourhoods, or do you think the world would be a much worse place because you can't hop on a plane and get to Tokyo in the next?
Well, if we're really speculating, maybe it could be the world could be a better place if cities would move themselves, like together with the people, or somehow if the notion that a city is about a kind of a static, encrusted organism which is served, would evolve into a much more kind of distributed biological paradigm in which resources are absorbed and released, and certain areas grow and then decay and then move and then intensity generates somewhere else, etc., etc. We were doing a little bit of research on Ulaanbaatar, which is the capital of Mongolia, a few days ago, and actually I was quite interested in discovering that originally the city actually had 25 sites. So then, at some point in history, it sort of settled, but the kind of original sort of core of the city, which was obviously pretty much related to a kind of nomadic civilization, etc., had 25 documented sites before settling down. I mean, I think this...
But in fact, the problem of transport and the consumption of resources is a problem only for the way it is framed within, meaning transport consumed by default. But if the production of energy is like cultivating, then today I have a bit of energy and I move. Tomorrow I don't have energy, I stay here. That's how the nomad were progressing, and I think it's an interesting model, no? The idea of cultivation and creating a tighter relationship between the entity, that can be the single person or can be the coach or can be the plane, and the production, no? So an understanding of an ecology which is not just about rain and growth, but is really an ecology that integrate artificial system on it.
I mean, clearly...
That respond to that. So it's not about moving or not. I move if I can. If I cannot, I don't move, you know.
But like clearly there is, clearly there is a very critical problem. Let's say, at the moment, like when you talk about, for instance, renewable energies, and you talk about harvesting energy, everything is still framed within a paradigm of large plants managed by large companies which harvest energy in one spot. Obviously, like the logic would be that for renewable energies, you kind of harvest them wherever they exist, wherever they are possible, and this means completely reorganizing, re-infrastructuring the whole thing, which is not very favorable for many reasons, for the perspective of the kind of energy giants. But on the other hand, it's one of these key elements, that define how movable, how dynamic, how responsive cities or people might be to the opportunities that they find in them.
But it's just it's quite current, obviously, the H2, the discussion of
Yeah.
being railway.
Yeah.
People are arguing it's great for the cities it's connected to, it's good for the cities.
Yeah.
But other people say no, the money is better spent in local communities and dealing with the local buses and things. So where do you stand on that? I mean, do you have a view, or is your analysis going to have a contribution to this great debate?
Clearly, if you think about a distributed system or distributed intelligence, you kind of favor distributedness. I don't know if it's also because I'm Italian, somehow the idea of this kind of meshwork of small centers that are kind of highly interconnected kind of resounds with me. I always been not very kind of a favorable of a high-speed train, although sometimes it's quite interesting and useful to go from Milan to Turin in half an hour. But at the same time, I think this also depends a lot from the actual dynamics of the particular place. I think in Italy, for me, it doesn't make a lot of sense. Maybe in England, it may do a bit more. I'm not too sure, but
Yes, well, quite interesting to take up some similar subject. What I like of your research is the capacity of evolving and breaking through into different disciplines that are largely not necessarily architecture and urbanism, and use them in a very productive way and using, say, new knowledge. You also said in the lecture that there is a certain optimism now about ecology and sustainability. I share the same view. I there's quite a lot of confidence. I think, more or less, we know how to make a sustainable building. And the question, I try to phrase it in a very simple way. I think we know how to make a sustainable building, but the question is, I think we know very little how to make a sustainable community. And the question is, what's your take on that, and whether your trajectory that's in your radar, and perhaps the next, possible research, whether to work alongside the biologists, maybe to work alongside a sociologist, and whether you see that as a evolution of your research.
Claudia, this is for you.
Yes, the answer is yes. I don't like so much the word sustainability in itself, but in terms of, it goes back to the point he made about the nodes. I think, as I said, as Marco mentioned, the idea of distribution and smaller nodes is something we are favorable towards, and we think is an interesting direction. Having said that, it's probably not the only direction. As I said before, I'm more interested in the idea that there are units of different scale. There is the community, there is a single person, there is a larger scale. Each of the units has got its speed and a certain relationship to energy. And what is important for me in a sustainable community, if you want to call it like that, is the way there is more reading or awareness from the different units, from the single person, from the community, and etc., of the different fluxes. If you have a reading of the energy that goes in and goes out, then you can start to understand the pattern of this and act accordingly. Whether you are an individual, you are a community, or you are a larger city. That is what is interesting for me, and what makes probably a community, in my opinion, more sustainable. That's why we always talk about simulation, but we also talk about sensor, or we talk about people gardening, people cyber gardening, and etc. That's where the way we intend it, no? I think we think, and this inherent in our work, this idea that there is a disconnection between the way we produce and the way we consume or live. While we are for a reading of this pattern and understanding of these fluxes, not only a rational understanding, going back to Beatles on the idea of the ecology of mind, also an intuitive one. No? You don't need to know the exact number, but if you know the pattern of it, then you act accordingly, and that is integrated in your everyday practice, and that's becoming interesting for me.
But I mean, at the same time, I don't see like the algae research, for instance, necessarily, let's say, separated from dealing with community. Because I mean, as a designer, you need a medium, no? You need a kind of entry point to engage with a reality or with a complex situation. And I think that, you know, the research we did on algae, it's our entry point, for instance, or is one possible entry point. Of course, in the future there may be others, but I think the question is like the way we have been trying to develop interfaces that operates at different level, from the regional scale to the actual one-to-one experience, is quite literally a way to engage the notion of participation, the notion of interaction, and for me this is pretty much at the core of a kind of a more evolved idea of sustainability, where effectively there is a kind of almost like daily kind of feedback. And it doesn't mean that everyone needs to start cultivating algae, because probably in kind of urban environment, a lot of people have other stuff to do. But I think the question is, how do you establish links or connection between these different systems, social system, environmental system, mechanical system, building system, infrastructural system, that suddenly there is communication across. So in a way, these projects, the way we understand them, connecting back to the kind of cybernetic notion, is really as a sort of communication devices, if you want, no? That kind of somehow allow for these different systems and different regimes and different scale to kind of send little bits of information back and forth, and therefore influence each other. And I think maybe this is the way we sort of understand these levels together.
Too long sessions of presentations today.
Yeah, that's great. We started at 4, and it's good.
We should maybe let you rest now. Thank you very much.
Cheers.